student attempts to answer the following question. Given that x is an obtuse angle, so that means it's between 90 and 180, use algebra to prove by contradiction that sine x minus cos x is guaranteed to be greater or equal to 1. And the student starts the proof with our normal proof by contradiction method, and that is to assume the opposite of what we want to prove. Now we know that x is obtuse, that's just like decided, but we're going to assume the opposite. And going from that, they then square both sides, and we're asked to pick it up from here. So, okay, let's do it. Let's multiply the bracket out. We would get, this is sine x minus cos x times sine x minus cos x. So I'm going to multiply the bracket out. I'm going to get sine squared x. I'm going to get cos squared x. Then I'm going to get a minus sine x cos x and then another one. So minus 2 sine x cos x. And that is less than 1. Now this bit here is actually equal to 1. So that means that minus 2 sine x cos x is going to be less than 0. And I can divide through by minus 2, give me sine x cos x is greater than 0. You can alternatively add it onto both sides and then divide through by 2. Okay, so we're going to try and show that that actually can't be true. And it comes down to remember that x is obtuse. So I'm going to draw a little sine graph. And what we see is that for obtuse angles here, sine x is positive. You can maybe just even state that fact if you're using cast diagrams, then look, we can see it's positive in this quadrant between 90 and 180. Let's do the same for cos. Now we see that cos is actually less than 0 for obtuse angles. Again, because there's an S there, we can see that from the cast diagram as well. And so we can just finish by saying, yeah, sine x greater than 0 and cos x less than 0. So sine x cos x will be also less than 0. But this is a contradiction because we've said it's greater than 0. That means our assumption at the very beginning falls apart because that's the only thing that we've not just kind of implied. We've made this assumption. So therefore we can make the opposite conclusion that sine x minus cos x is greater or equal to 1 for obtuse angles. Okay, so slightly different, but it's we're still using the main ideas of proof by contradiction, starting with a opposite assumption and trying to get a contradiction. I've just got one more comment to make. I've got a small issue with this step here, because just because something is less than 1 doesn't mean that we can then just square it and keep the inequality as it is. For example, if you have minus 4 less than 1, if you square both sides, you get 16 and 1. Actually, the sign swaps around. So students kind of, for me, missed that little bit out. It's like we're only asked to pick it up from, this point here, and the question is not getting into those technicalities, but I just wanted to address it because it wouldn't for me be a very good proof. What we really need to say is that this thing here is definitely bigger than 0, because remember, we've said that this is less than 0, sorry, greater than 0, and the cos x is less than 0. So the thing on the left is greater than 0, and then hence, because both are positive, you can square it. But that does need to be addressed. You might say it's implied, but I think in a really thorough proof, you should just say that is the case. So anyway, I just wanted to talk about it at the end. Otherwise, it's a solid proof to prove this statement.